Hey guys, welcome back. In this video we will be learning the last topic of ray optics, which is optical instruments. And as you know that we have 4 optical instruments to learn. One is simple microscope, compound microscope, telescope and what human eye. Okay, so let's start. So first we are learning simple microscope. Okay, simple microscope, nothing, just a normal convex lens is there used to zoom your objects, right? Okay, so here what we need, just a thin convex lens. Okay, simple microscope is consist of just a simple lens only. That's what your convex type of lens. Okay, and in order to make a large image, what we do, we put the object like close to the lens, means like between focus and the optical center. So as you know that when you put the object between what focus and optical center for a convex lens, it will make a virtual image, right? So when we are doing this, a virtual and large and erect image will be seen to us, correct? So which will be a magnified image. So look here, this lens we need, first thing you understood. And where is the object placed? Object is placed between focus and your optical center, right? So in this what will happen? You say that an enlarged means magnified, erect and virtual image will be formed. Yes, we know that when you put the object between focus and the optical center for a convex lens, image will be what? Virtual, and it will be magnified, means larger than the size of the object. So look here how it works, very simple. This is what your lens, correct? Okay, there is a focus on this side, that's focus on this side. You put object anywhere, like you put here, this is optical center, you know, right? So you putting your object here, this is your object of height h0, correct? Okay, so how the image will form? Ray coming parallel will pass through what? Focus, like this way. A ray passing through optical center will look like that way, right? So here is what your eye, this is what your eye. So when you watch this object, okay, virtual image form. How you extend this rays backward. Okay, there is not enough space, so you should extend them straight backward like this way. They will meet here. This is what your enlarged image will be formed here, HI, correct? Yes. So we are interested, okay, first you understood we need what type of lens? We need a simple convex lens, thin convex lens, and object is placed between what? Focus and the optical center. So a virtual and enlarged image will be formed. This is a magnified image. Okay, now we are interested in defining that what is a magnifying power, MP in short we say. We call it what? Magnifying power. In short we say what? MP. What is the magnifying power of this any lens, any instrument, right now? So there is a definition here. Let me tell you what is that definition. Okay, simple meaning you already know that by what amount the image is enlarged, that's called your magnifying power. How the technically they define like in terms of the angle made. Suppose this is a, look here how they define the angle made by your image, like this is what your object, okay, this image making an angle of what? Say beta, correct na? So how they define? This is called angle made with what? Instrument, let's call beta. And suppose without instrument you watching an object, how it will look? I am drawing it here. Suppose you want to draw how it looks. This is some object, you want to see that object, and here is what? Your eye, this is your eye. Then you look at object like that way. This is angle made, let's call it alpha. So this is called angle made with eye, like you say naked eye or what? Unaided eye, without any instrument we watching that object. This is angle subtended with eye, and here with help of the instrument. So angle subtended with instrument. So how technically they define magnifying power? What is MP actually? What is this? Listen here, angle made with what? Instrument, correct na? Correct. This is called, people call it visual angle. You can write a word here, visual angle made with what? Instrument, correct na? That we calling beta symbol. And without instrument, with naked eye, or what is unaided eye, what is the angle made there? So you can write in here. So visual angle made with, you say, unaided eye, right now, normal eye without any help of instrument. This ratio is called what? Magnifying power. Okay, just generally like tan theta. Okay, because angle is very small here, so we know tan theta, sin theta all equal to theta itself, right? So suppose you want to write MP, right? Watch carefully. Normally what we see, object image will see a distance of what? D. What is D? D is the minimum distance of what? Distinct vision, clear vision. Is a distance, we know that at which distance, this distance we have to put object so that we can see what clearly. If we bring closer to them, we cannot see it what clearly. Even if we take it away from that point, we cannot see clear, right? So this is that minimum distance called what? Distance of distinct vision, clear vision, right now. Generally this is what? 25 centimeter for human eye. If not given an equation, we will take this as what? 25 centimeter. I will talk about this again. Okay, so let's see in this. This is what? Height of the object, or height of image, whatever you want to call, h1 let's call. So what is tan theta in this triangle? What is tan theta? Tan theta is called perpendicular to base, right? Okay, so let's talk about this. First, beta by alpha we need. What is this? This is a h1. So let's say, what is tan theta in this triangle? Look here, this is triangle. If you see, this is the triangle I am talking. So it's called h1 by what? That distance we calling what? Suppose not this, sorry, writing that is the distance of the object u. Okay, yes. So this is the height of the object, that's height of our image. So look here, h1, or just call it h itself, you confuse h, that also calling suppose h by what? U divided by, in this, h by what? D. H get cancelled, we are getting simply D by U. This is what your magnifying power formula, but we never need to use this because two cases we have always. I will write about that separately. Okay. So actually any instrument you have simple microscope, compound microscope, telescope. Generally image is formed at two possible places. One is called what? Image formed at infinity, or image formed at what? Distance of distinct vision, right now? Yes. So look here, one by one we will talk. Suppose I say first, simple case, image is formed at infinity. Your image is formed at what? Infinity. Then what is the magnifying power of a simple microscope? Magnifying power, what is formula? This is the formula, D by what? U. So image formed at infinity. Image formed infinity means where the object placed. Obviously it should be placed at what? Focus. Where you put your object at focus, you know the image is formed at infinity. What's the meaning of this? In this case you see that, in this case your object distance will be equal to what? Fe, focal length. Correct na? I am writing Fe, E means eyepiece. This lens close to eye is called what? Eyepiece. Okay. Yes. Clear? Okay. So what is the answer? Answer is this from here. Watch here, D by U. So D by what? Fe. This is your magnification. D is what? Distance of your distinct vision, or the minimum distance up to which we can see clearly by the focal length of what? That lens. This is what your magnification. D is what? Distance of, let's say, minimum distance of distinct is clear, okay, vision. If it's not given, then we will take as 25 centimeter. For a normal human eye, this distance is what? 25 centimeter. Means when you put an object at 25 centimeter from eyes, then image will be clear. We will see this what? Clear. If you bring it little close or little away, it will not be that much clear. Okay, maximum clarity is what? 25 centimeter. It depends eye to eye, but normally we will take this much. Okay, if not given in the question. Okay, so this is your magnifying power. Then second case we write here, image formed at what? D. Image is formed at what? D itself. Image is formed at what? At the distance of what? Distinct vision means clear vision. Then how this NP will come? We have write here our lens formula, 1 by V is minus 1 by U is what? 1 by F. Then we will get answer actually. So I am writing directly. It becomes actually 1 plus D by what? Fe. 1 plus, look here, just d by fe, here 1 plus d by fe, this is what your magnifying power. Okay, simple microscope, just you have to remember these two things only. Okay, yes. Okay, questions I'll do on them later once I finish all this instrument. Let's talk about second instrument, that's called what, your compound microscope. Okay, compound microscope is the extended version of your simple microscope. It used to even magnify more, right? Yes. So here we have what, two lenses. We have two, and what lens? Convex lens. Your convex lens is called what, your magnifying lens, right? Two convex lens we use here. One is called what, objective lens. Objective one is called what, eyepiece. The lens which is placed close to your object, that's called objective lens, and the lens which is close to your eye is called what, eyepiece, right? Here we have only one lens placed close to what, eye, so it's called eyepiece alone, right? Now, okay, so we have two lens. One is what, this one, and one is a little larger. Your eyepiece is bigger in size. Why? Look here, I'll talk. This is called objective, right? Now, objective lens. This is called your eyepiece. Correct? Yes. So this has the focal length of what, f naught. F naught means objective. This has focal length of what, fe. And always remember that in compound microscope, what will happen? Your, where I should write? Okay, I can write here. Your fe is always greater than what, fo. Focal length of the eyepiece is what, greater than the focal length of the objective length. This is what, small aperture and small focal length, both I can say. Let's say, let me write here clearly. Your objective lens property is what, objective lens, okay, which is placed close to object, is as what, small focal length and what, small aperture also. Aperture means diameter, right? Now, both are what, small. Why we need small? Because object will place close to this lens itself, so we need less light itself. Okay, less light means what, less aperture, right? Okay, why we need small? Because as object is placed close to it, okay, so we need what, small aperture, because you have to collect small amount of light. Okay, yes. While your eyepiece, this has what, has larger focal length and what, aperture as compared to what, your objective lens. Okay, this will be just opposite when we will talk about optical, that our astronomical telescope, because that light will come from very far, from infinity, so we need a large aperture of the objective lens to collect what, more amount of light. Okay, okay, so what's the procedure here? We put an object here close to what, your objective lens, right? That distance is called what, u naught, right? Objective distance for what, objective lens. Object distance, sorry, for objective lens. Okay, so let's draw an image due to this ray coming parallel. Say this is focus of this, will pass through focus. One ray passing through center of curvature, sorry, optical center will go straight. So these two rays will meet somewhere here, say here. So an image will be formed here. This is the image. Correct? Okay, so that distance will be called what, image distance. This is called what, v naught. Image distance for objective lens. Look here, three things: object distance for objective lens, focal length, and what, your image distance for objective lens. Now this is the first image formed due to first lens. Now this image will be an object for what, this eyepiece. This will be an object for eyepiece, and that final image will be formed. So suppose this object, and how rays will come, a ray coming parallel. This is a ray coming parallel, will pass through what, your, okay, ray coming parallel will pass through what, your fe, correct? Okay, focal length of the eyepiece. A ray passing through aperture will go straight. This will be what, straight ray, no change. So here will be what, your eye. This is what, your eye. You will watch from what, here. This is your eye, correct? So how the final image will form? These are not meeting, so you have to extend backward. Okay, so extend these rays what, backward, they will meet somewhere. Suppose they're meeting here. This is what your final image, enlarge final image. This is called H naught. This is called what? H dash, and this is final image HI. Correct? Yes. So 2 time magnification happening. You can see. You can draw this line properly. Okay. This is what your image form. Clear? Again, general 2 case will talk that final image is formed either at distance of vision or what at infinity. Then you write this formula again, right? Okay. First look here how you define magnification here. Look here, magnification MP. Magnifying power will what? Here we have 2 lens, right? Objective lens and eyepiece. So if you have 2 lens placed close, then I told you the net magnifying power will be what? Simply multiplication of the individual magnifying power. 2, 3 lens placed close, then what is net magnifying power? Like M1 into M2 into M3, it goes on, right? Yes, if they place close enough. So here 2 lens we have. So what is net magnifying power? Magnifying power M0 into what? ME. Clear? Net magnifying power is what? Magnifying power of the objective lens into magnifying power of the your eyepiece, right? Magnification. Okay. So look here. Again, as I said, the 2 final image is formed at 2 positions. Generally, we'll talk. One is formed at infinity. One is formed at distance of vision. Right now. Okay. So let's talk first about that. So first we talk case 1. Final image. We are not talking about this. We are talking about this final image. Final image formed at what? Distance of distinct vision. Means at D is your image is formed, final image. Final image is formed at what? The distance of what? Your distinct vision, least distance. Properly is called what? Least distance or smallest distance, after which we see what clearly. That's what your D is given. Then otherwise I said it's what? 25 centimeter. Okay, you have to take in calculations. Okay. So let's calculate. We want to calculate magnifying power. What is formula? Main formula M0 into ME. Correct. M0 is very easy. What is magnifying power? Here you know V0, U0, both you know. So you can write normal formula. What is normal formula for lens? V0 upon U0. Correct. That's what? Magnifying power. Correct. Okay. Then what is the magnifying power due to eyepiece? Look here, eyepiece, this is your formula. Image formed at infinity, then 1 lens, eyepiece, what is the answer? This much. So this will be your formula 1 plus D by Fe. That's all. This is the magnifying power where the image is formed at what? At a least distance of distinct vision. Okay. You can write this into many format because here this will remain same always, but this thing you can write in many formats. So like in terms of like image distance and object distance, but generally these we don't know. Image distance we know, we always know focal length and what object distance. So you can write here many format. Look here, you can write like this way also. This is simply magnification only if you watch carefully. So this is in terms of V0 unit. You can also write like this one. You can write F0 upon what? F0 plus U0. You can write like this way. Into what? 1 plus D by Fe. Or this in terms of image distance, object distance, in terms of focal length, object distance, you can write in terms of focal length and image distance is given like F0 minus V0 upon what? F0, right? 1 plus what? D by Fe. You can write this one. This all we have learned in what? Magnification, you remember, right? Okay. So, one more format. You can write in terms of what? This also you can write in terms of image and object height. This is what? Your object height. That's what your H dash is what? This image. Image due to what? Your objective lens. So, you can also write like this way. H dash, not final. Not this, okay? H dash by what? H naught 1 plus D by Fe. These are all ways. Main formula is this one. But maximum time I am saying what will happen, focal length of this lens and objective distance will be given to you. So actually this format will be easier. This you have to write with all sign convention, keep in mind. We assume that object is placed here, so light coming in this direction. You have to use this all formulas with what? Sign convention. Look here. This is what your light coming in, this is the direction of light. So object distance will be always negative. Correct now? We go in this direction. So U0 will be always negative. And focal length positive, object distance will be positive, right? Yes. Focal length of this lens also positive. Image distance, D, distance of vision, that will in that direction, right? So it will be negative. So be careful, you have to put all with what? Sign convention. Okay, this is the first case. Here one more question they ask the length of the tube. What they ask? Like these two lengths will be fitted in the tube, then you're watching right now. So they ask what? Length of the tube. Length of tube. First, what is length of tube? Simply distance between these two lenses. That's called your, like it's fitted inside a tube, something like that. Okay, yes. So length of tube is what? Simply the distance between what? These two lenses. Let's write here. Length of tube is what? Distance between the two lenses. Okay, this distance is called what? Simply length of the tube. So what is the length of tube in this case when image is formed at what? Distance of distinct vision. Right now, what is the answer? Look here. What is the distance between these two lenses? Look here. That much distance. This image distance is what? That is called what? V naught. Then this will be what? UE. This is object for the second lens. Yes. So this is what? Your UE. So what is the distance between these two lenses? V naught and what? UE. So magnitude of V naught plus magnitude of what? UE. This will be what? Your simply the length of the tube. Okay. Yes. And look here. This is called what? Your image distance VE for eyepiece. Right now, object distance is that one. Focal length and image distance what? That one, right? Now this can be what? Infinity, or this can be what? Your D. So actually in this case, image formed at D means your V is actually what? D we saying. Okay, yes. Now second case, image formed at what? Infinity. Then what happens? Okay, image formed at what? You should write here final image. Always say final image formed at what? Infinity. It means what? Your V is equal to what? Infinite. This is happening. Then how this formula will change? Okay, this will remain same only. Magnifying power is what? M naught into what? ME only. Say correct now. So look here. Everything will remain same only. Is what will change? Look here. If you watch carefully, like image from eyepiece. Okay. Okay. Eyepiece means what is the answer? Look here. Eyepiece means what? D by FE. Like here we wrote eyepiece means in case of image from the distance of vision, that is the answer, right? Magnifying power due to eyepiece. Same way, what will happen here? So this is your answer. M naught, no change, same answer only, like V naught by U naught only. So V naught by what? U naught. This M is what? Look there, D by what? FE. That's your answer. This is the magnifying power when image is formed at what? Infinity. So remember now, sometime in exam they will say that calculate this, calculate magnifying power or length of tube when image is formed at distance of vision or image formed at infinity. Sometimes they don't say, they use this word. One word they use that, they say normal eye. What they use? This word, relaxed eye, these, that find magnification for relaxed eyes. Find magnification over what? Normal eye. Means what? This case. What case? Image found at what? Distance of vision. Please remember this. Okay. Yes. And this will be opposite in case of what? Astronomical telescope, when we learn next topic. So it's very important. Instead of saying this distance of vision, they can say what? Normal eye or what? Relaxed eye. Means this case they are talking. Okay. Okay. So generally when we talk now, when they ask numerical on this topic, they ask generally this topic only, right? Image found at what? Distance of vision. Okay. Okay. So this is what your magnifying power. If here they ask length of the tube, if they ask what is the length of tube here, length of tube, which is called L. What is the answer of L? Look here. Now if you watch carefully, look here. They said final image formed at what? Infinity. Okay. V naught remains same only. V naught only. This is your V naught. Like first image formed at distance, that's calling V naught. Now final image due to this lens is formed at infinity. Means where this object plays, that U is what? U should be equal to what? Focal length of this lens, right? Because when this object for this lens you're putting at focus, then image is formed at what? Infinity, right? So means that U is simply equal to what? Focal length. So what is the answer? FE. Magnitude only you take. I'm taking magnitude because just you finding normal length, okay, scalar thing. So we should not put sign convention here, just magnitude of them. So this is what your answer for the length of the tube in case of what? When image is formed at what? Infinity, right? So these two cases we have, here also two cases, here also two cases, and next topic also we have just two cases, image formed at distance of vision or image formed at what? Infinity. Okay, so now we'll talk about what? Astronomical telescope. Okay, so now we are talking about what? Third instrument, that's your astronomical telescope. So here also we need two lenses, but the arrangement of lens is just opposite to what your compound microscope. In compound microscope, your objective lens is of small aperture, small focal length, while eyepiece has larger focal length and what? Larger aperture. Here just opposite. The lens, objective lens, which is towards object side, that will what? That will have larger aperture and large focal length. Okay, because in astronomical telescope we used to see what objects which are placed at very far, so you say infinity. So the light that comes from infinity is what? Very small in what? Magnitude. So we need a large size lens to collect what? More amount of light. Okay, so look here. So first you know that used to see what? Far objects clearly, right? Very far. So look here, here also we have what? Two lenses. There is a big lens, big focal length and big aperture. Okay, yes. Okay, so this is called what? Your objective lens. In our exam they have asked properties, keep in mind. So what is the property of objective lens? Objective, large focal length and what? Aperture. Why we need? As light comes from infinite, right? Light comes from infinity, or you say very far, correct? Na? So need large size to collect light. Okay, yes. While your eyepiece, this will have just what? Small focal length and aperture as compared to what? Objective lens, right? Okay, so this is what your objective lens, which has large focal length. That focal length we calling what? F0, correct? So light coming now from infinity, means parallel rays will come, right? So let's say one ray coming and passing through optical center, it will pass straight, it will not deviate, you know, right? Like that way. Okay, one ray coming parallel to this, let's say like this, it should pass through the focus of this. Say that's your focus. Oh, I'm drawing little bad. Say this is focus, so they will meet what? Here. Okay, say they are meeting here. I drawn actually a little bit wrong, because you see we need a small aperture of what? Your objective lens, so they should meet, let's say here itself. Okay, this is looking little more good. So suppose they are meeting here. It's looking like focal length is very small, but the focal length of this lens is what? Very big. Do not confuse. So this f0. Okay, so these two rays came, they coming from infinity, they will come parallel. You see, one ray passing through center of optical center will go straight, one ray is passing to focus, they meeting here. This is what your first image form. Now near to this we have a small lens. This is your small lens. It's called what? Your eyepiece, correct? Okay, so one ray coming parallel will pass through focus of this, that's called Fe. One ray say passing through what? Optical center, like this. Okay, here is what? Again your eye. This is your eye. So if you extend these rays backward, they will meet somewhere. Let's say they will meet somewhere here. So this is what your final image position, correct? Okay, so here also define this NP. What is magnifying power? Technical definition remains same. The angle made with what instrument by what angle made with what? Your normal eye, correct? That's called your magnifying power. So how are you defining here? You say that, let's say this is equal to what? Angle, or you say proper word is called visual angle. Okay, visual angle made with what? Instrument by what? Visual angle made with what? Unaided eye. So this angle is suppose alpha, and that angle is what, your beta. Okay, so this is nothing but what, your beta by alpha only we are talking. Okay, yes. So again you want to write magnification in terms of this focal length and object distances, right now. So again we have two cases. Let's call first case, it's called final image formed at what, infinity. Final image formed at what, infinity. Correct na? This final image formed at infinity. Okay, yes. So what is what is magnification or magnifying power here? Okay, so look here, this simply becomes what, f naught by fe with a negative sign. This is your answer. If image is formed at what, infinity. This is also called your normal case or relaxed eye. Keep in mind, relaxed, like I told you there, relaxed eye. In case of compound microscope, relaxed eyes or normal eye means what, image formed at distance of vision. Right now here it is opposite. Here when image formed at what, infinity, is called relaxed eye. So what is magnifying power? Amp is what, is equal to minus f naught by f is simply focal length of that by focal length of this, right? Here length of tube they will ask you, length of tube again. So that L will be what, f naught just fe, addition of that. Correct? Okay. Second, final image is formed at what, d, distance of what, distinct region, right now. Yes, the minimum distance up to which we can see clearly. So is formed what here. Then what is magnifying power? MP. Look, what is the answer? Look like this one. It look like minus f naught by fe, that term only, 1 plus fe by what, d. This is a formula. That's you have to remember just this, f naught by fe, 1 plus d, 1 plus fe by what, d. This is your magnifying power. You know, maximum time this question they ask in exam like this one only. Look at this relation, magnifying power and what, length of tube, both are in terms of focal length. Okay, very important. Okay, rarely they ask this thing. Okay, here length of tube is what, length of tube will be equal to L will equal to, like here, what is length of tube when final image found at distance of vision. So like we wrote there also, so focal length first, that distance what, focal length. Okay, actually I wrote a little wrong here, this is what your focus here. Okay, because rays coming from infinity, image formed at focus. So this is f naught, please write it carefully, f naught is here, that point. Okay, so f naught plus what, the ue, so that distance will be what, ue for what, your eyepiece, ue, that will be your what, length of the tube. Okay, these two cases, main case is what, this one. Okay, now one more thing we have, eye, then we will do problems on this. So let's talk about eye. Fourth topic again, human eye. We will learn working of human eye, and mainly we will learn defects in human eye. So I should write that, defects in what, human eye. So it's a very general topic. Hope you already know that what type of defects we have in eyes, myopia, myopia, all these things you know already. So let's talk one by one. First defect is called myopia, right now? Myopia, other name is what, short sightedness or what, sorry, long sightedness or what, far sightedness, right now? Yes. Okay, so myopia, as you know that, already you know that in myopia what happens, we cannot see the far objects what clearly, right? Okay, why that happens actually, look here, okay, let's write words so you understand better. In this defect what happens, far objects cannot be seen clearly. So defect is this, that we cannot see far object clearly. Now we are asking that why we cannot see far object clearly, because of this. Look here, this is your eye. In this defect what happens, when you have this defect, no, this is your retina, right? This is what your retina, right? Okay, suppose rays coming from far, say coming from infinity, parallel rays are coming to like that way. So they should meet actually here. In order to see the clear image, these rays should meet at what retina. But in this defect, what happens? Yes, in this defect, what happens? Your lens becomes what? Thick. This lens, our human eye lens, that becomes what? Thick. If lens becomes thick, what happens? Focal length is what? Reduced. That we write here somewhere. In this defect, what happening? Lens become thick. Lens becomes what? Thick. So if lens become thick means what? Focal length is what? Reduced. Focal length is reduced. What happens? Focal length is reduced. So initially they should meet actually at this point, right? They should meet actually here. Correctly, they should meet at retina or screen, you say. Yes, but they will not meet here. They will meet here itself. Here they will make image. Correct. So this is a little short from the image. This is a retina or screen. Your image should form here, but it's little short from that. So this short, that's why it's called short sightedness or what? Near sightedness, right? Yes. So once more, lens becomes what? Thick. If your lens is becoming thick, means what is focal length will reduce. Thin lens has what? More focal length. You have two lenses, one thin like that one, means its curvature is actually very big. You draw a circle around, look a very big circle. If you have thick lens like this one, focal length is what? Less. Okay. More the thin lens, focal length increase. More the thick lens means focal length is what? Less. This is a thick lens, you say. This is what? A thin lens. Here f is what? More. Here f is what? Less. Correct. So in this defect, what happens? Due to your eye lens becomes what? Thick. Then focal length of the eye is what? Reduced. Focal length reduced means it will make focus before the retina, right now. So we not see the image clearly. So now how to rectify this? You know that how to, I don't know, I'm writing too much high. How to rectify, right now? So you know that we want to meet these rays at this point, means we have to diverge that. They're meeting before the retina, so we have to diverge them. So we need a diverging lens to correct them. So if you put a diverging lens in path of these, they will diverge and come back what? Here, right? So same thing only. Look here. This is what? Your eye. This is your eye lens, okay? Your eye. This is what? Your retina or your screen, you see. So normally rays coming like this way, and I'm saying they are meeting here itself. So image formed here. So it's not clear. Now you want to correct this. So you have to use a, how are we correcting this? By using a diverging lens. So you put a diverging lens here before the eye. This is a diverging lens. So this lens will divert this light little like this one. It will come here, that light will come here. So now they will meet at what? Retina only. They will meet on retina and make a clear image. Correct. So how to correct this? You write by using a diverging lens, right now? Diverging lens, or also called your concave lens. So concave lens is required to correct this defect, myopia. Other name, as I told you, is called short as sightedness, right now, or nearsightedness also called. Why? Short is short toward your screen. This is screen, but is the rays are meeting before the screen or before the retina. So it's little short from your retina. That's called what? Short sightedness. Okay. Okay. So here this defect we cannot see far object clearly. So now we talk numerically. Here numerically they will ask you that I want to correct your eyes, then what power of lens we should use, what focal length we should use, okay, like this. So here they will use a word. That word is called what? Far point. What point they will use? Far point. What is far point? Correct na? Okay, understand this defect, what happening? You cannot see far object clearly, right now. Then what happened? Up to some distance you can see clearly. So the maximum distance up to which you can see clearly, that last point, this is called what? Your far point. Correct na? So what is far point? Maximum distance up to which a person can see clearly. So far point for a person is what? The maximum distance up to which he can see clearly. or you say the distance after which a person cannot see clearly. Both ways you can say. What is far point? The maximum distance up to which he can see clearly, means near things he can see clearly, after that we cannot see clearly. So either you say that is the maximum distance up to which a person can see clearly, or the distance after which a person cannot see clearly. So actually what's the meaning of this? It means what a far point is simply what your image distance actually. At this point, if your image is formed, you will see what clearly. Correct? So this is numerically how you will understand. If far point is given to you, that is nothing but what? Simply your image distance. Okay. This is nothing but what? Your image distance. Please remember, it's very, very important. Far point means the distance up to which a person can see clearly. After that, he cannot see clearly. So object is placed after far point, then he cannot see clearly. So we need what? Then lens. So look here, suppose this is your eye. If this is your eye, and suppose this is what your far point. This is what your far point. Means up to this distance you can see clearly. And an object is placed, suppose here. This is your object. You want to see that clearly, then we need a lens. What should be focal length of that lens, that you will calculate. So look here, far point is here, means up to this distance, means in this range you can see clearly. After this you cannot see clearly. So that distance is simply called what? Your image distance. This is what your V. And object is placed here, so that's what your object distance U. So they will ask you now that we need to put a lens here, correct? Na? Which lens? Sorry, diverging lens, so that we can see this clearly. So what should be the focal length of that lens? F. What should be the power of that lens? So you will write here your formula. Which formula? 1 by F is equal to 1 by V minus 1 by U. This formula will write. Clear? Yes. Some important hint. Sometimes the far point is always given. Object, sometimes object distance will be given. They say the far point of person is what? 100 centimeter. Means up to 100 centimeter he can see clearly. After that he cannot see clearly. Then they say that he want to see an object at distance of what? 300 centimeter. Far point given means image distance given, object distance given. They are asking what is the power or focal length of the lens required. You can calculate. Okay. Yes. Sometimes this object distance will not be given. Just only far point is given. They said what power is required to see clearly. Then this object distance, what you will take? You will take as a what? Infinity. Right? You want to see clearly till what? Infinity. So what power you need? So very, very important. I'm writing here. If object distance is not given, if object distance is not given, then take it as what? Then take it as what? Infinity, right? Yes, object distance will call what? Infinity is not given to you. Once more, far point is the maximum distance up to which you can see clearly. So this is what your image distance means. Up to at this point, if your image is formed, you will see clearly. So after that you cannot see clearly. So object will be generally placed after this only. We want to see this object. Okay. So that's your object distance, image distance. You can find now focal length. See here you have to use sign convention. This is very important. Object is here. Light will go in that direction. This is the direction of light. Please focus here. Right. This is the direction of light. So look here. Your image distance negative, object distance also negative, focal length also negative. So all these three things are negative, means no need to change any sign here. So in this case, like we're talking about what? Myopia, your minus V, minus U, minus F, all are what? Negative only, correct? Are you understanding? This is the object here. Object place here, light is going towards like our eye, like that way. So from here you measuring distances, focal length, you're going this direction. Your image distance this direction, object distance also in this direction, so all are negative. Means in this formula you don't need to change sign convention, because all are negative is same answer only. Okay. Yes. Okay. Now let's move on and talk about the second defect. So I will do numerical on this. So it's very important. Object distance not given, we will take it as what? Infinity. Okay. Yes. Okay. I understood that far point is simply what? Your image distance. Okay. Yes. Let's talk second defect is called what? Hypermetropia, right? Okay, hypermetropia. Okay, yes. So this is called what? Farsightedness, right? Correct. So in this case, what happens now? In this case, what happens? Your lens becomes what? Thick. So focal length is reduced. Here opposite happens. In this defect, what first? A person cannot see near objects clearly, right now? Yes. This you understood, okay? He cannot see near object clearly. Now, what happens actually here? Okay, I'm writing here. So in this defect, what happening? In this defect, what? Your eye lens, okay? Eye lens becomes what? Thin. Eye lens become thin, so focal length is what? Increased. So focal length is increased, and due to this, what will happen? Your image will form afterward retina, behind retina, right now. So image is formed behind retina. So again we don't see the clear image, right? So if you want to see how it looks, so this is your eye, okay, rays are coming, this is what your retina. So this lens became now what? Thin lens. Okay, when thin means focal length increase, so the rays will meet what? Afterward retina. Say somewhere here. So they will meeting what? Here. That right little more clearly. So this much is what? Far from the retina. This is your retina. Correct? So means more diversion of the light happening. So you want to correct this opposite lens, you need what? A converging lens, so you can bend light even more and meet at the retina itself. So you want to correct this. So correction. Yeah, correction. How you do correction? So you need what? A convex lens. Here you need concave lens. Here you need what? Convex lens. Converging lens you need. So what you do, if you put another lens before this, like here itself I am drawing this lens, you put in advance. This lens itself convert like here little bit, like that one. Then they meet what? Here. Correct. This is your correction. Correct. Okay. So now look here. Watch carefully numerically. Here we call something called far point, the maximum distance up to which he can see clearly, after he cannot see clearly. Similarly, here also defined a point that's called near point. Okay, near point. Correct. So what is near point? Look, in myopia we cannot see far object clearly. So it's the maximum distance up to which we can see clearly. In this range we can see clearly. After that we cannot see clearly. Here just with opposite. In this range we cannot see. After that we can see. So how you define here near point? It is the smallest distance. It is the shortest distance. After which we can see clearly. Before that we cannot see clearly. Okay, it's the shortest distance after which a person can see what? Clearly. Write it carefully. So this is a distance after which a person can see clearly, right now. Yes, before that he cannot see clearly, because nearby objects he cannot see clearly. This defect, right? So look here, let me write here clearly. Once more, I was talking about what? Near point. So suppose this is your eye, you are here, that's your eye, and you are watching object. Suppose this is what your near point. What is this? Your near point. Means in this range you cannot see. Right now, in this range you cannot see. After this you can see. Means from this range onward you can see. In this range you can see, but in this range you can't see. Right now, here you can't see, because you cannot see nearby object. Okay, so the minimum distance after which you can see, this is what your near point. Right now, so again you see that image will be formed what? Here. This is what your image distance only. Right now, what you will call that distance? Again, what? Your image distance. Far point, near point, right? Both are what? Image distances, right? So here what object will be placed here between what? Near point and your eye, because here in this you cannot see clearly. Suppose object is placed here, this is your object. That distance is called what? Your objective lens, what? U. Correct. Then we need to put a lens here. We have to calculate the focal length of this lens so that we can see it what? Clearly. Correct. So object distance given, if it's given is okay, not given, correct na? Not given, then we'll talk about what? That is so simply equal to what? Your distance of vision, right now. You will 25 centimeter will take. Okay. So look here, I'm writing here. You write this formula 1 by f is equal to 1 by v minus 1 by u. Clear? Now listen carefully. So here in this case you understood this is what your concave lens, negative focal length or negative power. But here we need what? A convex lens, positive focal length, positive power. Okay. So look here, light coming this direction, right? This is the direction of light. Correct. So when you measure distance from this eye with this eye, your image distance this direction negative, object distance negative, but focal length is what? Positive. So here all were negative, all three were negative. So even don't put sign convention here, it's okay. But here be careful. Here V will be what? Negative. U is what? Negative, right? But F will is what? Positive. So you have to put proper sign convention here. Be careful. Okay. Yes. Okay. Like in this case, I told you object distance is given. Okay. Not given, then you take infinity. Here object distance given. Okay. Not given, then you take what? Distance of vision. If object distance is not given, then take it as what? D. D, which is what? 25 centimeter. Correct? This you will take. Okay. These were two defects, what? Myopia and what? Hypermetropia. Then apart from this, we have some other defects also. You know their names. Something is called what? Presbyopia, right? Both defects are there. Then this is called what? Presbyopia, right? Let me write few words here. Presbyopia means what? Both defects are there. Okay, just write. Okay, both myopia and what? Hypermetropia. Means the person cannot see the near object also clearly and far also he cannot see clearly. Both defects are there. So here we use both lens. We want to correct this defect. We need to use both lens, the convex lens and concave lens, are also called what? Bifocal lens, right now. Also called what? How we correct this defect? Correction we do by using what? Bifocal lens. Bifocal lens means both lens will be in one lens itself, your concave lens and convex lens. Okay. Okay. Then you have another defect called astigmatism also. Astigmatism, right now. In this defect, what happens? A person cannot see cannot see clearly like graded line. Means if you have like horizontal and vertical lines, this type of things, like you have this type of net, right now. Then he cannot see what? The horizontal vertical line clearly. If he can see horizontal clearly, then he cannot see vertical clearly, right now. So this defect is called what? Astigmatism. So you write few words here. I don't have space. Just write a person cannot see the horizontal and vertical lines clearly, right? Yes. So how we clear this? By using cylindrical. How you do correction of this? Okay. Of astigmatism by using cylindrical lens. Cylindrical what? Lens we use to correct this defect, astigmatism. Okay. Okay. So mainly numerically we have these two things. Now we will do problems on this, and I will do problems on other instruments also, that compound microscope and what? Astronomical telescope you have learned recently. Okay. Okay.